So, we're gonna be talking about piss. More specifically, how the urinary system works and how urine is formed. The urinary system produces, stores, and eliminates urine, the fluid excreted by the kidneys. The kidneys make urine by filtering waste and extra water from the blood. Urine travels from the kidneys into two thin tubes called ureters and into the bladder. The blood flows to the kidneys through the right and left renal arteries. Inside each kidney, these branch into smaller arterioles. The blood is at a very high pressure and flows through arterioles into tiny knot of vessels called the glomerulus. These are located in the nephrons. From the glomerulus, the blood pressure drops and the blood flows into the arterioles, which coil around the nephrons. These in turn connect to a series of small veins. These vessels reunite and ultimately form the renal vein. About 1/4 of the total cardiac output, or total blood flow, circulates through the kidneys. This equates to just over 1 liter of blood every minute. Now, there are 3 steps into making urine. Disclaimer, this isn't some DIY stuff you can do at home. This is not recommended to do at home, and it probably never will be. So the first step is filtration. The kidney is the body's blood filtering system. Blood vessels visit the kidney and enter a special ball of capillaries called the glomerulus. The glomerulus is nestled within a region of the kidney called the Bowman's capsule. This is where filtration occurs. As blood is pushed through the tiny capillaries, the high pressure forces some things to pass through the capillary walls. The walls act as a sieve or a filter, hence it is called filtration. Water, sugar, salts, amino acids, nitrogenous waste, and other tiny things enter the kidney as a substance called the filtrate. Cells and large blood proteins that cannot fit through remain in the blood vessels. The filtrate entering the kidney is like pre-urine. The second step is reabsorption. The filtrate enters the kidney in a proximal tubule. This region of the kidney is special because many things can be removed from the filtrate. These valuable things are recollected or reabsorbed by the body. Glucose, certain salts, vitamins, hormones, and amino acids are restored to the body and will not be included in the urine. Sometimes, if the body has too much of something, then the extra sugar or salt will stay in the filtrate. For example, diabetics with high levels of blood glucose may have their glucose in their urine since it cannot be reabsorbed. The filtrate after reabsorption is like pre-urine, so this is the step before the actual urine. The last step is secretion, so this is where it's actually urine. The filtrate then passes through a really neat structure called the loop of Henle, where it gains and loses water and salt. As it leaves the loop of Henle, it enters the distal tubule, where secretion occurs. Now, with all this urine, you would think that our bodies would become acidic. Well, that's not entirely the case. There are mechanisms that keep the blood pH in our bodies normal. These would be the buffers in our body, the respiratory and renal control. Buffers are solutions that contain a weak acid and its conjugate base. As such, they can absorb excess hydrogen ions or hydroxide ions, thereby maintaining an overall steady pH in the solution. The respiratory system can reduce blood pH by removing CO2 from the blood. The chemical reactions that regulate the level of CO2 and carbonic acid occur in the lungs when blood travels through the lungs' pulmonary capillaries. The kidneys help maintain the acid-base balance by excreting hydrogen ions into the urine and reabsorbing bicarbonate from the urine. Now, there are some scary things about all this, and that would be the alkalosis and acidosis. Acidosis is an excessively acid condition of the body fluids or tissues. Alkalosis is an excessively alkaline condition of the body fluids or tissues that may cause weakness or cramps. This should be taken seriously as acute metabolic acidosis may also cause an increased rate and depth of breathing, confusion, and headaches, and it can lead to seizures, coma, and in some cases, death. Symptoms of alkalosis are often due to associated potassium loss and may include irritability, weakness, and muscle cramping. That about wraps it up for this video. Anyways, if you like more of this stuff, let me know in the comments below. Leave a like on the video if you enjoyed it. Anyways, I'm out.